how can the law of gravity be checked against the moon's orbit? So this is an example that's going to be loosely based on the kinds of things that Isaac Newton was looking at to try to understand and figure out the law of gravity. So let's go ahead and take a look and see how this kind of plays out here. So it says we're going to start by analyzing the moon's orbital motion. We know that the velocity is tangential to its orbit. And without gravity, the moon would travel in a straight line. Now, we've argued before that if you compare an apple and the moon, they're both kind of falling by gravity. I kind of made the argument earlier, though, that like, well, an apple falls, the moon orbits. They really both just have accelerations towards the center of the Earth. But maybe we can look at this in a way that will be able to make their falls more comparable. So it says here in 1 second, the moon travels a calculable distance. And if there were no gravity, that's kind of what's shown here. This is how it would have traveled in 1 second. I don't know if that's really to scale there or not, but let's imagine in 1 second it does that. And then with gravity, it would be somewhere else, right? It would be right there. And I put a question mark right there that said the distance the moon falls could perhaps also be known. In other words, I'm going to associate the distance between these 2 points. In other words, where the moon actually goes as it orbits versus where it would have gone if it had just traveled in a straight line. I'm going to associate that with the distance the moon actually fell in 1 second. And now I can compare that to the apple's distance that it falls in 1 second, which is about 5 meters. And we know that, right, because that's like, 1/2 gt squared is the formula we might recall for that. If t is equal to 1/2 of g is actually slightly less than 5 meters, but we're just rounding it up to maybe a one significant figure number there. Now, the moon is about 60 Earth radii away from Earth's center, okay? And so 60, the square of 60 is 3,600, which is also the factor by which gravity is diminished. So I'm kind of in what I'm doing here, I put that question mark up for the moon, but when I'm considering this number of 60 squared, I'm thinking about Newton's law of gravity, and I think I have some of the writing from the last example up here, but the gmm over r squared. And one way of loosely interpreting this is that the influence of gravity on the moon is reduced by a factor of 1 over r squared, comparing the apple to the moon. In that sense, we're kind of comparing the apple to the moon as Kepler's third law would allow us to, compare different planets at different orbital radii, even though these are not really planets and they're not really, well, the apple's at least not orbiting. Anyway, but we are saying, again, that's the factor by which gravity is diminished. And I think the fact, like in the last example, that the mass of, in this case, was the planet, but that could be the apple or the moon, would cancel out. That kind of makes that comparison more valid. So a simplification of the calculation is to say, okay, the 5 meters that the apple fell in 1 second, if that is diminished by a factor of 3,600, accounting for how far away the moon is from the Earth compared to the apple, so we just take 5 meters divided by 3,600, and it turns out that gives you about 1.4 millimeters. All right, so we can look at that as like a prediction maybe. Now, it turns out the moon's orbital period of 27.32 days leads to the moon falling 1.4 millimeter. Now, I'm not showing all the details of that calculation, but basically, you need more information than I've shown there. You also would need to know the actual orbital radius of the moon. But basically, from all of that, you can calculate an observed value right here. So I'm looking at this second 1.4 millimeter is like based on observations of what the moon actually does. This is based on theory from what we know apples do near the Earth. There's something really cool the way I'm looking at this here, because I'm looking at this kind of like a science experiment, right? And in that sense, maybe if we look at history with sort of the hindsight of the scientific method, because that's not, the scientific method as we have it today wasn't really established yet, right? But so maybe cheating a little bit to look at it that way. But from a modern scientific method perspective, we could say, well, that first 1.4 millimeter was a prediction based on the law of gravity. The second 1.4 millimeter was based on the moon's orbital period. And what we do in science is we test things. We test things with the aim that it's possible that the thing we're testing could be falsified. So here we said it's gonna be 1.4 millimeters, and then it turned out observation says yes, It's 1.4 millimeters. Those two numbers could have been different. In that sense, like, what if this had turned out to be like 10 feet? Or what if it had turned out to be like, 1 angstrom or something like that, something super tiny? And, of course, maybe those are ridiculous ideas. But what if it even had turned out to be like 1.2 instead of 1.4? Or maybe 2.5? Something not all that different, but still enough different. If physics were a non-mathematical science, or really if science were just non-mathematical altogether, we could say, good enough. But science doesn't work that way. No, we're very precise about our predictions. These two numbers could have been different, but they weren't. They could have falsified the idea of the law of gravity, but they didn't. Instead, the agreement of these two numbers validated the law of gravity. And again, that's maybe not exactly how things played out historically. I'm maybe looking at things sort of through a modern lens. There's an argument for why that might be inappropriate to do. But nevertheless, it's a really good illustration of how science rigorously determines its results and subjects them to testing, so that if there's anything wrong, that we hope that comes out so we can revise our ideas.